Hi guys, now we have David talking about backtesting crypto trading strategies.
All right, thank you so much for the invitation. So I'm going to talk about backtesting crypto trading strategies. And yeah, my name is David Florysiak, and I'm currently at IU International University. Let me start with the, let's say, learning objectives or motivation. So how should we evaluate the performance of a trading strategy or of different trading strategies? To answer this question, I'm going to show you an example that uses a simple moving average trading strategy for cryptos, or more precisely for Bitcoin, but we can also choose like any different crypto or any different asset that you want to invest into. And so the idea of why I'm going to show you this is that if we test trading strategies, there might be things like multiple testing issues that arise through data mining, but I'm going to show you what this actually means. And I'm also going to offer you a potential solution for this, which is like adjusting the performance measure that you use to evaluate your trading strategy for this multiple testing issue. In our example, I'm going to show you how to calculate a haircut Sharpe ratio. So the related literature here is, or the main idea also of the haircut Sharpe ratio is based on an article by Harvey and Liu, published in the Journal of Portfolio Management, and which is entitled Backtesting. So what is the simple moving average trading strategy? It's a very, very simple strategy. It uses the idea of past prices to predict future prices of the underlying. If you believe in finance, that should not necessarily work, but that is a different question. So we're going to evaluate this trading strategy. So, and how do you basically implement the strategy? So what you have to do is you have to calculate a short-term moving average of the underlying price, and you have to calculate a long-term moving average of the underlying price. And if this short-term moving average is larger than the long-term moving average, this is a signal, according to the strategy, that there is an upward trend in the underlying. So what you do is you're going to long the underlying. And else, so if that is not the case, so then this is a signal for a downward trend. So you're going to short the underlying. That's the trading strategy, right? And so how do we now test if this is, so once we have like the returns for this trading strategy, so how do you test if it is actually profitable? So what we're going to do, and this is what I'm going to illustrate you in a minute, so we're going to calculate the returns for this trading strategy. So we're going to have like a capital T different returns. So many, let's say we look at daily returns, so we're going to have like thousands of daily data. And with mean mu and standard deviation sigma that we can then calculate or estimate from the historical returns. So, and what we're going to do is, so we're going to test the null hypothesis that the strategy is actually not profitable. So it's basically like equal to zero. So the average return is equal to zero in a two-sided test. And if you're familiar with the general idea of hypothesis testing, then this results in a T ratio like this one here. So which is a very simple standard T ratio. The T ratio is similar, if you just look at it, to the Sharpe ratio, how it is constructed if we test for a mu equal to zero. So then there is actually a relationship between the T ratio and the Sharpe ratio. Why is this important? Not at the moment, but we're going to make use of this later on if we look at the haircut Sharpe ratio. So, and so what we want to know, basically, how do we evaluate the trading strategy? So if we are able to reject the null hypothesis of the trading strategy being not profitable, then we would conclude that we have potentially a profitable trading strategy. And the idea is to calculate the p-value here, so of this two-sided test. And if the p-value is smaller than, let's say, a significance level of 5%, we would say we are confident with at the 5% significance level that we discovered a profitable trading strategy. We need to make a few assumptions. IID normal, returns, t-statistics for the t-distribution, and we have t-1 degrees of freedom under the null hypothesis. Okay, let's test the trading strategy. So here you're going to see my code, and so I'm going to import like a few packages and set a few settings. So here we're going to use Bitcoin prices. Let's see if I just like execute the cell, you're going to see that we have the last 2000 observations of Bitcoin for the last day as of today. So this is not the current price. I think I downloaded this morning. But this is the prices, this is the timestamps, right? So now to implement the trading strategy, we need to set, we need to calculate the short-term window, the short-term moving average and the long-term moving average. So for each, we have to set like the number of days, which we are going to use to calculate the rolling windows. And for the short-term window, let's say we take 40 days. And for the long-term window, let's say we take 160 days. If we do this, we will see here we have the Bitcoin price and we have the 40-day short-term moving averages and the 160-day long-term moving averages. No? Okay, and how does this look like? Graphically, it looks like this. So we have the Bitcoin price in blue, we have the orange, the short-term moving average, and the long-term average. And you can see sometimes the moving averages are like, of course, they have to be on top of each other or below each other. And so according to our trading strategy, whenever the short-term moving average is actually larger than the long-term moving average, this is the long signal, and otherwise it's the sell signal. So let's see how this looks like here. If we do this, there you go. And here you can see we just added a column with a position. So here, for example, on the 25th of December, the short-term average is smaller than the long-term average, is a sell signal. So we are short. How does this look like in a graph? So we can just like also put the position into into this graph, and then we see here, for example, the orange short-term is larger than the blue long-term average. So this is a this is a buy signal, so we are long the underlying, right? And this changed here at the beginning of 2022. All right, so that's basically like the strategy in general. So let's backtest the strategy. So what we're going to do is we're going to calculate the returns, and I added the column of the buy and hold returns. This is just like the basic log returns. And if you were just like long into crypto, but if you conduct a strategy, obviously here on the 11th of November, so this would be, we are short Bitcoin, so our return would be 4% plus. So because we multiply the position with the buy and hold return. And so if we invested like either buy and hold or strategy, this simple moving average strategy, so this would be for the sample that we look at for the set of returns, result in an annualized return of 21% for the buy and hold strategy and 53% for the simple moving average strategy. And the annualized volatility would be 70.8%. And then we can calculate the Sharpe ratio if we have the mean and the standard deviation, and the strategy Sharpe ratio is 68%, and the buy and hold Sharpe ratio is just 26%. So the t statistic here that would result would be 1.52 for the strategy. That's the one we're interested in. And you probably also, if you're familiar with the statistics, so 1.52 as a t statistic, this is not significant. So let's check. The p-value is actually like 12%. So this is above every significance level where we would say we're confident to reject that this is a profitable, not a profitable trading strategy. All right, so, but now we chose like these different, let me show you, window lengths, like we set them to 40 and 160. So let's see if we change them, whether we can get a better result in the backtesting. And what we're going to do is we're going to optimize this. So we're going to look at different combinations of the short-term days for the rolling window and the long-term. Yeah? So now we take like all the combinations, 45, 115, 60, 115, and so on. So we're going to do this here in this column, and basically now do this exercise that we just did for this one strategy with the one combination of long-term and short-term windows. We're going to do this now for all of these combinations. It's much more than 1,000 combinations, and going to show you the results here. So let's hope that this works. Yeah, it worked. And what you can see is it is the table that results from all the combinations that we tested. So here, for example, short-term window length 85, long-term window length 46, the resulting annualized Sharpe ratio, the t-statistics, and the p-value. And what is the optimal strategy according to this? What maximizes our annualized Sharpe ratio? It's actually like the short-term length of 10 days and long-term length of 100 days, which results in a p-value of 0.3, which is smaller than 5%. So we would reject the hypothesis that this is not a profitable trading strategy. So thus it is a profitable trading strategy. But guys, I mean, how many tests did we do here? So we were testing 1,360 different trading strategies on this very same data set. Let me go back to the slides to raise this issue that we have. So this is an issue of multiple testing. So if you test one strategy, that was the example that we did in the beginning. So just one strategy with this one parameters 40 and 160. So statistically speaking, what is the probability that we are going to find a profitable trading strategy if we set a significance level of 5%? You can show that this is actually 5%. So in 5% of all the cases, we should find a profitable trading strategy. If we test not only once, but if we test, let's say, 10 times, so our probability that we find a profitable trading strategy increases dramatically. So just imagine, so we test one, we didn't find a profitable thing. We test another one, we didn't find one. We test another one, we didn't find one. We just test until we find something. And so if you just test 10, then you will see that actually the probability that you will find a profitable trading strategy increases to 40%. Yeah? And here is the relationship that actually like calculates this value. So to account for the multiple testing, so this is the probability, so the p-value for multiple testing. But I'm going to skip the details of the mathematics behind here, but it just does exactly this. So it accounts for the probability or for the number of tests that we actually conduct. And so it increases the probability, the p-value. So let me show you back in the slides. Here, the maximum the p-value of the maximum annualized Sharpe ratio was actually 3.7% if we just conducted one test. If we conduct if we account for the number of tests that we actually conducted here, the 1,360, I'm just going to apply the formula that you see in my slides, and the resulting p-value is actually 1. It's 100%. So if we conduct 1,360 tests in this setting here, given the data set and the characteristics of the data, we have a probability of 100% of finding a profitable trading strategy. This will probably not hold in reality. So so we should probably not invest into this trading strategy. But what can we do? How can we adjust our performance measure? We were looking at the Sharpe ratio, and what we can do is actually we can account for this multiple testing by calculating a so-called a haircut or adjusted Sharpe ratio. So what would be the resulting Sharpe ratio if we accounted for the number of tests that were actually conducted? What we do is we're just equating the p-value that we calculated for multiple testing to this expression here and back out the haircut Sharpe ratio. This is very simple. Let me illustrate this to you. So because we have this here, this p-value column, and if we then just say, okay, what would be the resulting Sharpe ratio if we actually had a p-value of 1, so 100%? So let me see if I scroll down. So we're going to look at, yeah, so if we have like a p-value of 1, it is close to 0. The Sharpe ratio is close to 0. So adjusting for the multiple testing, you will see that actually this is not profitable and the Sharpe ratio is 0. Okay, let me go to the conclusion slide. Evaluating the profitability of trading strategies should account for multiple testing. This is what I tried to illustrate you in a simple example. So there are potential solutions for this, for example, a haircut Sharpe ratio, or there were other multiple testing frameworks that I cannot just look at because of the time. And yeah, multiple testing methods in general are designed to limit incorrectly discovering a profitable trading strategy. All right, so that's everything from my side. Happy to take any questions.
We've got one question from 44 calls. Would it be possible to get access to this notebook file in order to replicate, test it ourselves?
Sure, sure. I mean, I can post it on GitHub if you want.
Awesome. So yeah, and I think Lawrence will be able to sort access out for others for that as well. Well, look, thank you for that, David. Guys, the recording will be up in 30 minutes, a raw version, so you can view it. Later on, it'll be up on YouTube as well. And finally, I've dropped a link into the Discord there where you can continue the discussion with David. Again, I'd like to thank David for his time. I think from the looks on Discord, it's a very insightful and engaging talk. So great stuff there, mate.
All right, thank you.
All right.